Chapter 8, Lesson 6, Multiplying a Polynomial by a Monomial. Alright, so we talked about polynomials and monomials earlier. Basically what this really comes down to is your old friend, the distributive property. So in example A, we have 4z multiplied into the quantity here, here, and here. So basically you just follow the rules of multiplication and the rules that you've already seen in algebra. We have, so what they've done first, I can back up a little bit, was they combined like terms. If you notice that there was a z squared and a negative 3z squared inside the term, they simplified it, they combined those first to give you negative 2z squared. You can do that. Certainly that's advantageous for you to do that first. At any time, always combine like terms before you do any massive procedure like distributive property. So now we have 4z squared being multiplied into here. So 4 times negative 2 gives you negative 8. Z squared and z squared, well, that gives you a total of z to the 4th. And now we multiply 4z squared times the last thing in the term. So we have 4 times 7 gives you 28. I have 2 z's and another z. That gives me 3 z's. It's a positive times a positive, so I get plus. So there's my answer there. Negative 8z to the 4th plus 28z cubed. All right, now in situation B, they want you to solve this. And the first thing you have to do, since the two terms are not similar, because if they were similar, you could do something completely different. But since they're not, you will have to use a distributive property. So I have 4n minus 20 plus 2 equals 30 minus 5n plus 3n. All right, combine like terms, just like you did in situation A. So I have 4n minus 18 equals 30 minus 2n. All right, at this point, this goes all the way back to chapter 3. Get the variable to one side, get the constant to the other. I'm going to move the 2n, additive inverse, cancel it out on the right-hand side. I get 4n plus 2n. That gives you 6n. Minus 18 equals 30. All right, so I have the variable on the left-hand side. I want to move the constant to the right-hand side. Additive inverse. Instead of subtracting, I add. Cancel out the 18. I get 6n equals 48. At this point, 6 is being multiplied by n. To undo that, you do the inverse, which is to divide. 6's cancel out. N equals, what should this be? 6 goes into that. How many times? 8 times. Okay, so 6 goes into 48 8 times, so the n is 8. All right. Try these couple examples together. In number 1, make sure you use the distributive property. Be a little bit careful here because there's a negative 2 on the outside. So when you multiply that in, we get negative 4a minus 16. All right, now over here in number 2, we're going to take the monomial CD and we're going to multiply it in. So 6 times 1 is 6. We have 2 c's being multiplied by another one, so we have c to the 3rd. We have a d that comes along. And we have a positive times a positive, so that's plus. And then we have 3 times 1 gives you 3. We have a c and a c, that gives me c squared. And we have a d and a d, so that's d squared. All right, so there's the answer there. On page 2, again, more examples of just a monomial being multiplied in using the distributive property. Let's pick number 5. I have 8 times 2, so that's going to be 16. I have a total of 4 s's. I then have 8 times 4, that's 32. A negative times a positive gives me subtraction. And I have a total of 3 s's. And then I have 8 times 4 again, that's 32. A positive times a positive gives me addition. And I have a total of 2 s's. So it's s squared. Notice that it's arranged in descending order, which is the traditional way to do it unless told otherwise. Number 6. Well, we'll do this one because it has some fractions in there, and for a lot of kids, it's a good thing to just real quick refresher. I have negative 1/2 xy squared and the quantity 2/3 xyz plus 1/3 x minus 8. All right, let's take care of the variables first. I have x and x, that gives me x squared. I have y squared and y, that gives me y cubes. And then I have z. All right, now in my thinking box over here, I have -1/2 being multiplied by 2/3. Have to remember that when you multiply fractions, you can multiply across the top, multiply across the bottom, and then simplify, or you can simplify before. Well, I have 2 divided by 2, so that's just 1. So now across the top, I have 1 times 1 gives me 1. 1 times 3 gives me 3. I have a negative times a positive, so my overall fraction is a -1/3. Now, since I have something on the top here in the numerator, I don't need the 1 there, but I definitely need the 3 underneath. I also need that negative. All right, so now we're going to take the -1/2 xy squared on the outside, this, and we're going to multiply it to the second piece. So I have a negative times a positive. Well, that gives me subtraction again. All right, so I have 1/2 multiplied by 1/3. So I have another little thinking brain down here. I have 1/2, 1/3, multiplied. Well, there's really nothing to simplify here. I just basically get 1/6. So I'm going to put a 6 on the bottom because I know I'm going to have some variables on top. I have x multiplied by x. I get x squared. I have a y squared, and there's another y's, so I get y squared. All right, last thing we need to do. Look at the constant versus our term that we've distributed in so far. I have 1/2. You really should not have to do any math out for this. You have half of 8. Well, that will be 4. You have a negative times a negative. There's positive. And you have your variables on the outside, but there's no variables on the inside. So it's just going to be xy squared. There's your simplified answer there. Again, it's very similar procedures, just these problems are getting longer and longer. Number 15. We have a rectangular garden is x feet wide. So again, it's a geometrical problem. Draw yourself a shape. It's x feet wide. So here's the width. The length of the garden, so obviously we have L. The length of the garden, L equals 3 feet more than, so 3 feet more than. So that must mean plus 3. 3 feet more than twice the width. Twice the width. All right, I'm going to write a polynomial that represents the area of the garden. Well, I remember that area equals length times width. So I can take this and substitute it in place of L. So area equals 2W plus 3, and the W is the W. Oh, look at that. That's your beautiful distributive property. Yes, you should simplify this. So area equals, distributed in, 2W squared plus 3W. There's your simplified area formula. If you have any questions, please see your teacher.